Okay, all right, let's get started. I hope you guys are doing okay. Thanks for coming to class. And today I want to cover some basics of our data structures. But before I even get into that, I want to talk about just how you should configure your computer. I want to make sure everyone has things configured correctly, just because it makes a big difference when it comes to like doing your homework and whatnot. Okay, so one of the biggest things that that you really need to do is you need to use folders in your computer. Okay, so there's a tendency to just click the file, download the file, the homework file. So, homework 1's posted and you can download the homework file. And some students just kind of start working directly from the downloads folder, okay? And you don't want to do that just because your downloads folder is probably super cluttered. There's probably hundreds of items in there, and the different pieces can get mixed up. If you download the same file more than once, it's going to get kind of renamed into something else. It's easy to mix up different versions of your things. So it's going to be important to create folders, all right? And in fact, so probably you might have a folder already for Stats 1 and 2A. And within that, you should create like a homework folder, or at least a folder for homework 1, a folder for homework 2. Keep your homework separate. Homework 1, 2, 3, etc. And then what you'll do is you'll download all of the related files to go into that particular homework folder. In general, don't use spaces in your file names. Use underscores instead, maybe dashes. But don't use spaces, just because accessing them in a script or something gets messy. All right. So, as far as this first homework assignment goes, you'll want to download the instructions, and then it's important that you have both of these files, the monthnames.txt and the homework output.rmd file, in the same folder. Okay, just because when you open up the homework 1 output file, and that's the file that you're going to be working on, it's going to look for monthnames.txt, and it's expecting to find it in the same folder. So make sure it's in there, okay? As you work, the place where it looks for files and stuff is going to be your working directory. And if you ever run into the problem where it says, hey, I can't find this file, or I can't open the connection or something like that, it's probably because your working directory is not set correctly. And so you can do that in RStudio by going to Session in the menu, and then look for Set Working Directory, and you'll set it to your source files location. Again, this is under the assumption that you have your files organized into folders. This is not going to work if you just have everything in your downloads folder or something like that. Okay. So yeah, this is the kind of this is an error message that you might encounter. It'll show up like in red text. Okay, it'll say something like cannot open file monthnames.txt or something like that. If you see this, that means it can't find. It's looking for this file because the instructions or the script calls for R to open up the file, and it can't find it. All right, and that means this file does not exist in the working directory, and that's either the file is saved somewhere else on your computer, so it's not in the same directory as the homework file, or your working directory is set to the wrong location. So again, go through and just make sure you've got your folders set up, you have the files in the right place, and you have your working directory set. Okay. So again, error messages are helpful in pointing you in the right direction. And so if you see this kind of error message, it means one of these things is going on. Okay. Another thing that as you work in R, so let me go ahead and open up RStudio over here, your environment is going to start filling up with different objects. Okay. so so up in the way I have my panes configured, if RStudio will start up. Okay, something's going on. All right, well anyway, the environment's going to start filling up with different objects, and okay, I don't know what's going on here. Let's kill these tasks. The computer's going to be mad at me. All right, let's try this again. All right, I don't know, it's having trouble loading. You know, you'll get, this is going to fill up, and you should get in the habit of periodically clearing out your environment, okay? As your environment, as you work, different objects will start appearing there, and you want to kind of make sure that in your RMD file, whenever you create an object, you have the line for creating that object in your RMD file. Sometimes you interact with things in the console. The console affects the environment, but it's not going to necessarily make changes to your RMD file. So you want to make sure. Okay, here we go. So chances are, you know, let me just kind of show you. So in the homework, all right, so you have different files or different stuff, and as you're kind of like working here, okay, you'll notice these things appear over here. And you might make modifications, right? So you might say like x1 is going to be like 5 or something, right? And this changes things. And as you interact with your functions or the console here, things in the environment will change, and that could affect things when it comes time to knit. Okay, and so if you run into problems when you are knitting, okay, chances are the environment that you have locally in your working session is different from the environment set up by the RMD document. So to kind of get everything to line up, I recommend that you delete all of the objects by hitting the little broom, okay, and that kind of sweeps everything out. And then you can run through your RMD file line by line to kind of make sure everything works out, okay? You can also type it yourself. You can run this command rm list equals ls. That is equivalent to hitting the broom icon for deleting everything out of the environment. But the broom icon is a quick way to do it. Okay, so this is probably the most common error or message that gets posted on CampusWire, and it's something along the lines of I can't knit. Okay, that my script runs, I get it, it runs on my computer just fine, but when it comes time to knitting, I keep running into errors. Okay, and the most kind of common scenarios that causes this looks something like this. Okay, you create an object in R, all right, and you modify or delete the lines of code that create this object, but that object still exists in the environment, and so new lines of code that reference that object still work. However, because the lines of code that create that object are either different or have been deleted from the RMD file, when it comes time to knit, okay, those lines don't exist, and so therefore the object that you've been interacting with either doesn't is different or doesn't exist. Okay, because the whole point of an RMD file and this knitting process is this kind of idea of reproducibility, that you can take your RMD file, give it to someone else, they can open it up on their computer, and they can run it and produce all of the same results that you have, okay? And so when you knit, it goes under the assumption that your environment starts off completely empty. So it always starts off with an empty environment, runs through each line of code, and so if your code references an object that wasn't created in that RMD file, it's going to error out, okay? You might have created it on your computer, and so when you run it locally during your current session, it runs because that object exists on your computer, but it's not, that command to create it doesn't exist in your RMD file. So that's what's going to happen. So the way you can resolve it, okay, save the files that you have, then delete everything out of your environment, and start at the very beginning of your RMD file and run your code one line at a time, or one code chunk at a time. Okay? And most likely what's going to happen is somewhere along the way you're going to encounter an error message that whatever error message you encountered when knitting, it'll probably be the same error message that you'll encounter as you're running it line by line. And when you encounter that message, you can see what caused the error, which line caused the error, and that should provide some insight as to what's going on, okay? And you can kind of clear the environment and run through every single chunk of code. And if you are able to get through the entire RMD file after clearing the environment, you should be able to knit without any kind of problems. Okay. All right. Sometimes you run into some really stubborn issues, and you can't get the thing to work by kind of following this process of just clearing the environment and then running your RMD file one code chunk at a time. Sometimes when you're knitting something, you still encounter some kind of error message, okay? So this is another way to kind of resolve the problem or troubleshoot, all right? This is just troubleshooting advice, right, or debugging advice to kind of fix really stubborn issues, okay? And so the way you'll do this, okay, is, again, save all of the files you have, clear out your environment, okay, and then create a brand new RMD file, okay? And when you create a brand new RMD file, call it something like fresh RMD or whatever you want to call it, okay? And then knit that file right away, okay, right after you create it. It should knit because it's brand new. There should be no problems, okay? And then you can delete any kind of unnecessary stuff from that thing. And then what you'll do is you'll go to the one that's not working, your kind of original homework one full file or whatever, and you'll copy one paragraph or one code chunk at a time from your original file into the fresh one, right? So you copy one paragraph over, and then you knit it, all right? And it should knit, all right? And then you go to the next thing. You copy a code chunk over, and then you knit it, okay? And you keep doing this, copying stuff from over here, the old one that's not working, over into the fresh one. Every time you copy a chunk over, you try knitting it again, all right? And hopefully it knits every single time, but then eventually you'll probably encounter some kind of error message, right? If you copy everything from over here over to here, and then it knits, then your problem's solved. There was nothing to troubleshoot. But probably you'll copy something over, and then suddenly it'll stop knitting, all right? And so that means the problem exists in whatever that chunk is that you just most recently copied, okay? And you can kind of verify by just kind of deleting that most recent chunk and then try knitting again. And then if it knits that time, then you know that one chunk, whatever it is, that's the problem, okay? And then that should help you isolate exactly where things are going wrong. Okay, did you have a question? Yeah, there is a debugger in RStudio, and you can set breakpoints, and as you are working within a function, you can explore all of the values and kind of the environment that exists within that function. So that certainly does exist. This is more so referencing knitting. So knitting is a little bit more than just kind of debugging a function. It's like it's the process by which R kind of renders text into LaTeX and then runs the code and produces output and all of that stuff. And a lot of times things go wrong. But yes, absolutely, there is a debugger in RStudio. I mean, right here, you can just, let's see. Hold on, where is, okay, so if I have a script, okay, so, if I want to just say like new is a, function of x, we're going to just do like, 1 plus 2 plus 3, okay? You can click, all right, so I have to save this somewhere. All right. So you can click on the left point, and this will create breakpoints and whatnot. And then as you are, all right, so you can do x is, I should do like y is 5, and z is 6, okay? And then so we'll just do new of 3, okay. So I'll save this, and then so I can set breakpoints at each of these locations. So when I do this, hold on, let me click set. Oh, so source. All right, so as I'm, when I click source, it's running. And so right now it says, this is my environment, and it has x is 3. And then as I run to the next thing, the next breakpoint, it has run the y is 5, and that shows up here. And then I click continue, and then it gets, now z shows up in the thing. So there's a way, you just kind of click on the left-hand side to get your breakpoints. Yeah. If you're not familiar with the debugger and this didn't make any sense, don't worry about it. We'll cover some more stuff here later. Okay. Okay. And this is also important, especially for students, international students. And this is, I recognize this is very Anglo-centric, but set your language, your R language, to English. Okay, set your R language to English, because if your language is not English, then your error messages will contain foreign characters, and then LaTeX is going to choke, okay, because it doesn't know how to render these things. So if you encounter something like this, LaTeX error Unicode character, and then something shows up here, it says that's not set up for LaTeX, then that's the problem that's going on. So sometimes, within the homework assignment, you deliberately want to create an error message or something like that, and you want to make sure your error messages are in English. Also, when you search for help, okay, sometimes one of the most powerful things you can do is just copy and paste your error message into Google or whatever search engine you're doing, right? You just copy and paste that error message and see what it is. And you will find much more results for error messages in English than you will for any other language, okay? So it might be the exact same error message, but in a different language, might just find a couple results, whereas if you search for the error message in English, there's just generally going to be a lot more results. That's just how kind of coding is set up. And so to kind of set your language to English, here's a couple links on how to do that. Okay. Another bit of advice: don't save your workspace. Don't have RStudio automatically save your workspace. Okay. And there's two things, and then this one's also really important. Do not restore R data into your workspace at startup. When you restore R data into your workspace at startup, there could be some objects in memory or some packages that get loaded that could end up affecting the way some of your functions run. Okay, and so again, that issue where when you knit, it's not working, but it seems to be working when you interact on the console and things like that, that could stem from the fact that at startup, your configuration ends up being different because this R data file is being loaded in. Okay, so make sure this is unchecked, and then save workspace to R data on exit, set to never. If you do actually want to save your workspace, you just click the save button. It's not a big deal, but just don't have it automatically save. Okay. All right, so that's that. Okay, let me give you your first view quiz answer, which is the letter E. E as in elephant. E as in elephant. Okay, you can comment by just kind of putting a little hash mark, right? And I think you guys are familiar with that. And this is kind of like the very most basic form of debugging, okay? So our studio does have a debugger and whatnot, but kind of your most basic form of debugging is just throwing in a bunch of print statements here and there so you can kind of see like what is the value of a thing, and then as you want to kind of turn on and turn off certain statements, you can just use the pound character. You can also just use Command-Shift-C or Control-Shift-C to kind of toggle things, okay? And then sourcing scripts, Control-Shift-S and whatnot. This is it's a handy little shortcut there. Okay, and then other useful shortcuts are right here. So knitting is Control or Command-Shift-K. All right, I've got quite a few slides covering kind of basic data structures. A lot of this is review from Stats 20, so I'm going to kind of go through this content, I don't know, relatively briskly, but if any of this you feel like, oh, that doesn't feel familiar or something, slow me down, okay? But I think a lot of this should have been covered in Stats 20, and a lot of this is based off of material from Hadley Wickham's textbook, okay? Advanced R, and he has a first edition and a second edition, and there's actually quite a bit of change between the first edition and second edition, and he's got a chapter on vectors and chapter on data structures, so that's what we have. Okay, so pretty much, so everything in R is an object, and kind of the most important family of object is the vector, okay? You have, and in R we have atomic vectors, and then we have lists, which is also another kind of form of a vector. And vectors are just these one-dimensional data structures, okay? The difference between an atomic vector and a list is that in atomic vector, okay, all of the elements in an atomic vector must be of the same type, okay? Whereas in a list, you can have different types of data values, even other objects and other lists within a list, okay? The overarching structure is still one-dimensional, okay? But you can have other kinds of objects within the list. As far as the basic data types that can go into an atomic vector, we have 6 basic data types, okay? And we have the logical, the double, which is basically floating point numbers. Any kind of number with a decimal value is a double. We have integers, so our whole numbers. We have characters, so that's like our string data. We also have complex, so that's going to have things like the imaginary number components in there. And then you also have raw values. Generally, we probably just use the first 4 most commonly, okay? And then the mode is pretty much the same. It's just that double and integer are, their mode is numeric. So, and the naming of R is a little bit weird. Numeric is, sometimes you'll see numeric in parentheses, and that almost always refers to double, okay? And then when it is integer, it'll say integer, but sometimes you'll see like numeric for double, but the working mode is both of these are numeric. It's a little wonky, okay? R will just kind of convert between integers and doubles automatically. The distinction isn't needed. There is a upper limit for how big your integer can be. There's also an upper limit for how big your double can be. Doubles generally can have at most 16 significant figures, okay, around 16 places after the decimal, and for bigger numbers, just 16 significant figures. So doubles are stored with floating point precision, which has a limit. whereas integers are stored as exact integer values, but I forget what the largest integer, I want to say 2 to the 32, I think, or no, 2 to the, yeah, maybe something less, but maybe 2 to the 16, and then there's a plus and a minus, or I don't know. Okay, well, there's a limit to the integer. I want to say 2 to the 32, but I forget off the top of my head. Okay, and then your default numeric type is double. So anytime you type a number into R, it's basically just going to be a type double. If you want it to be an integer, you can use a capital L after the number, and that will tell R I want it to be integer. And then also if you use the colon operator to kind of create a range of values like 1:100, that will also be integer type, okay? So if you just create a vector 1, 2, 3, that's going to be type double, whereas 1:3 is integer. Just the number 1 is double, and then 1L is going to be your integer, number 1, okay? Lists is, again, another one-dimensional structure, okay? And they are super flexible because a component within the list can be any R object, including other lists, functions, matrices, whatever you want in there, okay? And so that's the list, okay? If you take like a atomic vector, but you make it two-dimensional, then you have a matrix. A matrix, all of the values in the matrix have to be of the same data type, okay? Similarly, like an array is just a higher dimensional structure. All of the values have to be of the same data type. So everything in the, everything in your matrix is probably like type double, okay? A numeric matrix. But you can also have a matrix where everything's a character or everything's a logical value. That is possible. But usually you have a matrix of numbers, and most common form would be type double, but matrix of integers and things like that. If you want to have a two-dimensional structure where you have different types of values, you can have a data frame, and it's basically a list of column values. And so you have like this column is character, and this column is type double and things like that. We don't have a mixed data type for anything higher than two dimensions. Okay. Vectors can also have attributes, and that's either the atomic or the list. Their generic vector can have attributes. Attributes itself is another list, okay? And it's a list of just arbitrary kind of information. We call this metadata. Kind of the most important attributes when you do have attributes are going to be things like the dimension attribute that would turn an atomic vector into a matrix or array if needed, and a class attribute if you're using the object-oriented system in R, with the S3 object-oriented system, which we'll cover kind of later, but not right now. Okay. This is questions for your self-quiz as you're going through your notes. How much do you know here? Okay. So you can get your attributes by typing in the function attributes and putting in the object there, and then you can also get or set attributes using the attr function. So here is a data frame. Okay, this data frame is called trees, and this consists of 3 columns. I don't know, it's information about trees, and you can get the girth, height, and volume of the tree. I don't know how they measure these things, but anyway, this is what we have. Here I just have the first 6 rows, but there's more rows in our table. Okay. I can ask for what are the attributes, and our attributes, when you look at a data frame, we have the names, which are basically the column names. There's also the class attribute, and this will tell me what kind of object it is. This is a data.frame object, all right? And then row names, it's a little strange, but the row names are just the integers, 1 through 31. We have 31 rows, and then, so we have 31 rows, 3 columns. So our names are, the column names, girth, height, volume, and our row names are 1 through 31, okay? Now, this attributes is just a list, okay? And you can kind of think of it as, you have some kind of object, right? This is the object of interest in R, and then it's just kind of like taking a piece of paper and then stapling it on, okay? And so, I don't know, the most important pieces of information on here are things like the names and the dimensions or the class. Those are kind of be important, but it's just a piece of paper. You can write whatever else you want to do, right? So it's kind of like when you order something on the internet and then they throw in an invoice slip into your order. Like, it's going to have important information about your order, but if the worker wanted to draw a little smiley face on your invoice, they could do that, okay? And you can do the same thing. I mean, it's not common, okay? But you can, right? So you can just set an arbitrary attribute in your attribute. Here I'm going to call this info, and then I just decided to throw in a little piece that says this data frame is about trees, and then that now shows up in my attributes, okay? And you can put in every other kind of, it's just an arbitrary like piece of paper that gets stapled on to the object there, okay? I've given you, what, one answer so far? Okay, let me give you your second answer. Second answer is the letter B. B as in bear. Second answer is B as in bear. Okay, a matrix is, in R, the way R handles a matrix is that it is an atomic vector, and then we just throw in a dimension attribute, and we just make it two-dimensional or something like that. So here I've got the vector 1 through 10, and then I could, and if I say, hey, what's the class? It just says, hey, that's an integer vector. I can just say, hey, you know what, I want to set a dimension attribute. I want it to be 2 rows by 5 columns. And then what it does is it kind of reflows our data, and R works column-wise. So the values 1 through 10 get reflowed, 1, 2, 3, 4, 5, 6, into a 2 by 5 matrix there, okay? And now this object, I can say, hey, what are the attributes? And it will say, hey, you've got dimensions, 2 by 5. And I say, hey, what's the class? And it says, hey, it's a matrix. And a matrix is a type of array, right? So we get two things listed here. Now, if I want, I can turn this matrix, which is this 2 by 5 thing, back into an atomic vector by just deleting the attributes for dimensions. I can just say, hey, it used to be 2 by 5, but you know what? Get rid of the dimension, turn it back into an atomic vector. And so I can delete that. I can just say null, assign null. Null is kind of like the nothing, all right? So I want to set my dimensions to nothing, and that turns it back into a vector, okay? So you can kind of swap or transform it, okay? Similarly, here I have an array, or not an array, I have an atomic vector with the values 1 through 12, and I can make it into an array by assigning the dimensions, and I give it 3 dimensions. I want it to be 2 by 3 by 2, okay? And this is gonna be 2 rows, 3 columns, 2 layers, or 2 sheets, okay? So it's a 2 by 3 by 2, okay? So it goes down, I have a 2 by 3 here, and then a 2 by 3 here. That's created using array, right? You can also create an array using the function array, much like you could create a matrix using the function matrix, but you can also kind of reflow your data using by setting in a dimension attribute, okay? All right, internally, data frames are actually just lists. They are lists of vectors, and the vectors have to be of the same length. So if we're talking about this trees data frame, what it is the list, and each of 3 vectors, and each vector is length 31. We have a vector for girth, length 31, a vector for height, length 31, vector of volume, length 31. And R kind of glues those together and forms our data frame. When you ask what are the class of this data frame, trees, it says it's a data.frame. But if you ask, hey, what is the internal data type, it recognizes that at its core, it's just a list. Okay, it's a list that we kind of spruce up and make pretty by printing it this way, like in a table. But at its core, it's just a list. Okay. We also have other data structures. We have the factor. Okay, the factor is used to represent categorical variables. Now, internally, a factor is stored as an integer vector, okay? And then you have an attribute called levels that kind of turns the integers into categorical representations. So let's say I have this vector. Right now, it's a character vector, and I have the values m, f, f, x, m, and f, okay? And let's say I want to make it into a factor. I just do that. And then when we ask, hey, what does this factor look like? It prints out m, f, f, x, m, f. And the levels are f, m, and x, okay? Internally, the levels is just a character vector with the letters f, m, and x. And internally, the gender factor here is stored as an integer, okay? If I said, hey, I want to see as integer, what is it? MFFXMF is translated into 211321, okay? Basically, it looks at the levels, right? The levels, we have F, M, and X. X corresponds to 1, M corresponds to 2, X corresponds to 3. The default is it puts the levels in alphabetical order, and so, M corresponds to level 2, and so internally as an integer, you get 211 for MFF, and so on and so forth, okay? Now, sometimes weird stuff can happen, okay? Let's say you have this vector, 0, 1, 10, and 5, and somehow it gets turned into a factor, okay? And so it looks like this, 0, 1, 10, 5. It says level 0, 1, 10, 0, 1, 5, 10, okay? Now, if you this is stored as a factor. It looks like numbers, but it's stored as a factor. And so if you try to calculate the mean of a factor, it's going to give you an error. It's like, hey, you can't calculate the mean because the factor is for categorical variables, right? It's kind of like if we have a red car and a blue car and a white car and a black car, right? And I say, hey, what is the average car color? Like, what's the mean? Like, that doesn't make sense, okay? I guess you could picture like pouring paints in together or something, but there's no mean of like different car colors, right? And similarly, when you have a factor, a categorical variable, you can't take the average of it. Mean only works for numeric values. So R understands this, and you've got something, 0, 1, 10, 5, and you say, hey, you can't take the mean of that, okay? But now you might be like, oh, well, I know a little bit of R. I know how to convert things into numbers, right? So you might try to do something like as numeric, right? You might try to take the factor and do as numeric, 1, 10, 0, 1, 10, 5, and then take the mean there, okay? And when you do that, you get 2.5, okay? Which is like, what? What's going on, right? Because 0 plus 1 plus 10 plus 5 adds up to 16. We have 4 numbers. Our mean should be 4. When I do as numeric, I'm getting 2.5. What's going on? Well, when you do as numeric on the factor, remember internally it's stored as integers, 1, 2, 3, and 4, okay? And then it's just corresponding the levels, like the 1 actually corresponds to a 0, and the 2 corresponds to a 1, and the 3 corresponds to a 5, and the 4 corresponds to a 10. Like, that's internally what's going on. And so this 0, 1, 10, 5 is stored internally as 1, 2, 4, 3. The mean of that is 2.5, okay? But that's probably not what you want. If you wanted to actually do something like this, you'd have to first convert the factor into characters, and then you'll get 0, 1, 10, 5. Then you convert those into numbers, and you'll get the numbers 0, 1, 10, 5. And then you can take the mean of that, and then you get the number 4. That feels like a lot of work. And probably you should be asking yourself, why am I trying to take the mean of a factor in the first place? Because again, you're trying to take the mean of a categorical variable. Okay, other things with factors, you can't, like here, if you have the levels are f, m, and x, and you try to assign something that doesn't exist, you get an NA, and NA gets produced, okay? Atomic vectors, again, in R, every value in there has to be of the same data type. And so if you try to mix different data types, R does what we call coercion, okay? And basically, if you have logical values, integer values, double values, character values, they get coerced into a single data type where, character is least restrictive, logical, the true, false, Boolean values are most restrictive. And what it will do is it will look at the least restrictive type and then coerce everything into that least restrictive type and then combine them into an atomic vector, okay? So these are self-quiz questions for you to look at later. But here, if I combine the logical, the integer, and the double, okay? The least restrictive type here is the double. And so it's going to coerce true and false into double. So true becomes 1, false becomes 0. The integer gets coerced into double, so the 1 becomes a 1. And then so we get 1, 0, the true, false, the 1, and the 5, 6, 7 get combined. Okay? And this is going to be type double. When I combine a logical double and character, it looks at the three types. Character here is the least restrictive, and so it's going to coerce everything into character type. So this time logical, which is true false, gets coerced into the character's true false. Okay? The integer 1 gets coerced into the character 1, and then A, B remains character, and so the resulting vector becomes true, false, 1, A, and B. Okay? Things will get coerced into numbers just kind of automatically when you apply a function that expects a number. So here I have a logical vector, false, false, and true, right? And now I can explicitly coerce it. I could say, hey, turn these into numbers, 0, 0, do as numeric. And that's gonna, the false becomes 0 and the true becomes a 1, okay? But I don't even have to do that. I could just take this logical vector, false, false, true, and just throw it into sum. Sum is expecting numbers, and because it's expecting numbers, it's gonna automatically coerce the falses and trues into numbers, zeros and ones, and add them up, and it will just get the total number of trues, okay? And similarly, you could ask for the mean. The mean is gonna expect numbers. It's gonna coerce false, false, and true into the number 0, 0, 1, and then what's the mean of 0, 0, 1? You get 0.33. That's gonna be the proportion that's true, and that's gonna happen with any kind of function or operator that expects numbers. So if you do something like a plus or something like that, that will also automatically coerce values. Okay. Again, you can explicitly coerce things. So you can say, hey, force false, false, true into character, and you get the character false, character true. You can take integer values 0 and 1, coerce them into logical, and 0 becomes false and 1 becomes true. Now, if you try to do something and R doesn't understand what you're trying to do, right? You've got this character vector dog, and you say make it a number. R is going to say, I don't know what you're doing, so you get an NA. NA is for missing values. Okay. Just some of the rules. Pretty much everything, when you do as logical, okay, as logical, everything gets coerced into true other than 0. 0 becomes false. Everything else becomes true. Nan, which is not a number, gets coerced into missing, okay? So 1, -1, 0.1, negative infinity, something very close to 0 but not quite 0, okay? So this is 2.2 times 10 to the minus 308. I think this is like one of the smallest values you can represent on the computer, but it's not 0, okay? That becomes true, okay? Whereas 0 is the only thing that gets false, becomes false, okay? As far as values of false and true that are character things that are accepted for spellings of false, so capital F becomes false, all caps false, capital F and lowercase false. These get coerced into false, and these get accepted into true. But lowercase f, that does not get coerced into false, okay? And then cat, or other things will not get coerced. What's going on here? Why didn't 0 and 1 get coerced into false and true here? Yeah. Yeah, these got, because I combined them using C into the, characters F and T, this became character 0 and character 1. Character 0 and character 1 will not coerce into false and true. Whereas if you do as logical on the number 0 or the number 1, that will get coerced. Okay. All right, we have, here's a question for yourself later on. NA, null, and nan, and I guess there's a blank page in here. Okay. NA is used for missing values, okay? You can throw in, there's a missing value for each data type, okay? And so you can throw in a missing value into a logical vector and it will remain logical. You can throw a missing value into a character vector and it will remain character. You can throw a missing value into an integer vector and it will remain integer. And so internally, R actually has different NA types, okay? They all just show up as NA, but they will not kind of coerce things into others, okay? Now, if you want to check if something is missing, do not use the equal sign, okay? The equal sign is checking to see if two things are equal. NA is a way to say something is missing, okay? So it's kind of just like, I have a value in this bag. You don't know what it is, but the value exists, okay? It's some number. It's a number. There's a secret number in this bag, okay? I have a secret number in this bag, okay? And the question is the number in this bag equal to the number in this bag? That's what the equal sign is asking, right? And what's your answer? Your answer is, I don't know, right? What's the number in this bag? I don't know. What's the number in this bag? I don't know. Are they equal to each other? I don't know, right? And so R is just saying, I don't know, okay? Is the bag equal to each other? I don't know. But you can say, hey, do you know the value in the bag? Is this known or is it missing? Yeah, is it missing? Yeah, that's true. We don't know what it is, okay? Null is used to represent the null object, which is basically for things that do not exist, okay? That's the difference between, that's not NA. NA is something exists, but we don't know what it is. It's a missing value. Null is kind of used for things do not exist. Kind of the analogy I like to use is, let's say you're putting information, writing information about a person, okay? You can have a person, their name, their age, okay? And you might have a spot for, spouse and spouse's age, okay? Now, if the person has a spouse, but you don't know the spouse's age, you write NA, okay? If the person is single and has no spouse, you would write null for the spouse's age, okay? You would write null because it doesn't exist. Right? So null is for things that don't exist. NA is for things that do exist, but you don't know, okay? Checking for things there's null, is you do type, okay, bye, is type of null and is null and things like that, okay? The length of null, it's a little bit strange. The length of null is 0, okay? And if you try to kind of do work with null, you'll get like length 0 vectors. If you try to do null plus a false, okay, you'll get a length 0 integer vector because plus is going to return a thing. If you try to throw in null into a vector, it's not going to, it's basically putting in nothing there and things like that. Okay, we're basically out of time. I think you can kind of look at these, and I think you're familiar with this concept of vectorized math, where if you got 1, 2, 3, and 100, 200, 300, it's going to kind of line them up and do the math accordingly. I think in Stats 20, you also talked about recycling, where like it's just going to repeat the things and things like that. So look over these last few slides on your own time, and we will end there. Okay. All right. Last view quiz answer for today: the letter A. A as an apple. A as an apple is our last view quiz answer.